Hi viewers, welcome to this video lecture on machine learning, and specifically we are going for this random forest algorithms. So we have covered a number of algorithms previously, and in this video we are going for this random forest algorithm. So we'll see what is this random forest algorithm and how it works. Let us have an idea about what is this. Random forest is a supervised learning techniques, as we know, and it is used both for the classification as well as the regression problems. And the principle is that it is based on this ensemble learning. What is this ensemble learning? Combining multiple classifiers to solve complex problem and to improve the performance of this model. So this concept we call it as the ensemble learning, right? And this random forest, it is a classifier that contains a number of decision tree. Previously we have gone through the decision tree. We are using only one tree, and we are taking the performance and everything. Here we are taking a number of decision tree, and we based on the average we are finding the random forest, right? So we summarize like this: random forest is a classifier that contains a number of decision tree on various subsets of a given data set and takes the average to improve the predictive accuracy of the data set. That is the meaning. So we will explain it here more vividly. So instead of relying on one decision tree, the random forest takes the prediction from each tree, and based on the majority votes of prediction, it predicts the final output. Okay, so the greater the number of trees in the forest leads to higher accuracy and prevents the problem of overfitting. Okay, so this is the principle on which our random forest algorithm works. Now if you see this diagram here, we have some training set here. Training set is the data set what you are taking, that divided into training and testing. It may be 70, 30 or 80, 20, in between it can be there also. So this entire training set is divided into data set 1 or training data 1, training data 2, training data 3, and this training data 1 is fed to one decision tree, that is the decision tree 1. So training data 2, it is given the training decision tree 2, like that n number of decision tree, and the data which is split into n number of training data, that is fed to that one. So out of that, so this decision tree, it will get some output, and this will get some output, it will get some output. So based on that we go for, suppose the same data set we apply to this decision tree 1, 2, 3, 4, then there will be some prediction. So what is the majority voting? Suppose the prediction is coming out of a fruit, it is coming something mango. So out of 20, 15 came mango, then the voting is mango. So then you come the prediction, yes, the image is mango, okay, or the fruit is mango, right? This is the thing it happens, right? Why we use this random forest? So it takes less training time, that is the important thing, as compared to the other algorithms, and it predicts output with high accuracy. The accuracy is more here. Even for the larger or the large data set, it runs efficiently. That is one of the important things why I use this random forest. Next, it can also maintain accuracy when a large proportion of data is missing. So thing is that when data is more, data set is big, so it is also good here. Second thing, if some data is missing, in that case also it is useful, right? So this is the why we go for this random. And how does random forest works? All the procedure will go step by step. Random forest works in two phases. First is to create the random forest by combining n decision tree. The second is to make a prediction for each tree created in the first phase. So now let us follow the following steps. Step 1, select random k data points from this training set. Okay, the training, suppose 80% of the data we have taken as the training set. Out of that we divide into k data points, right? So this select the random k data points. K data point is a subset of this training set. You get it now? Now build the decision tree associated with the selected data points, that is the subset. Now we build decision tree for each data points. There are k, so k number of decision tree is created. Now choose the number n for decision trees that you want to build. How many you want to build? Out of that you decide some n number of I am going to build it. Then this step is repeated, 1 and 2 is repeated. Now for new data points, suppose I want to, this is the test data, find the prediction of each decision tree and assign the new data points to the category that wins the majority votes. So what I told you, that suppose I selected 20 number of data points, so 20 number of decision trees created. So the entire fruits what I have given the input there, so it has to predict what type of fruit is this, right? Got it now? Suppose out of 20, 15 or 16 they predicted it is mango, and 3-4 they predicted no, it is something like guava or something like that. That because of the majority of voting, so now the decision is taken, it is mango, right? Now this working of this algorithm can be better understood by the below example. Suppose we take this example here. Suppose there is a data set that contains multiple fruit images, let it be. So this data set is given to the random forest classifier, and the data set is divided into subsets and given to each decision tree, and during the training phase each decision tree produces a prediction result, and when a new data point occurs, then based on this majority of the results, the random forest classifier predicts the final decision. Okay, so now let us take the image here below. So this is the instance. You can see in a basket we are having a variety of fruits here. Flowers are also there, but we are worried about the fruits, not worried about the flowers, right? So in that fruits, it is we are giving a number of decision trees. Say here a decision tree, can you see here left hand side, it is one, it is another, and dot 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 dot, that means a number of decision trees are there. And the k point of this data set, suppose there are 5000 rows of data is there, some 100 we put it here, some 500 put here, something like that k of that. Based on that, suppose this decision tree, it classifies it is apple, and this decision tree classifies apple, like that. Some decision tree it classifies no, it is a banana. So like that we will say the majority voting. So suppose 70-80% of the people voted that yes, based on this prediction it is apple. So output is the final class is the suppose I am putting the same thing here, the same k point, so it will predict it is a apple, right? So this is the thing. What is the application of this random forest? We can apply in banking, we can in medicine, land use, marketing, all these places we can use it. Okay, so this is the thing. And what is the advantages? It is capable of performing both classification and regression, as I told you that, and it is capable of handling large data set with dimensionality. The dimensionality is also more, that means number of attributes are more. It enhances the accuracy of the model and prevents the overfitting issue. That is the why we are going for using this thing, right? So now it is the time so to move to our algorithm. Now I go for the decision tree based this thing, right? So now let us have a look at this thing. Suppose I am going for this implementation with the Jupyter notebook, that is Anaconda 3.9 something version we are using. So you can check it here. Yeah, it is giving Python 3. So now what we need to do it here, we import some libraries, like I import pandas as pd, import numpy as np, import matplotlib .pyplot as plt, import cborn as sns, like this. That are things, and the style also are putting the direct grid, right? So pip install py.plus, that we installed, and it is also complying. Yes, this version, this thing is there. So that you for py.plus also we can install, right? Then you can also import this py.plus. So import py.plus, it is okay, fine, it is imported up to 4, it is fine. Then 5 from ipython .display import image, right? Then I have to take a data set. So I take the data set from this Kaggle. I put it pdd.read underscore csv, the is income underscore evaluations .csv, that I read it and assign to the df. Okay, so df is the income underscore evaluation .csv. Now if df.head, we want to see the first 5 lines. So this is the age, what is the work class, the state government or something like that, what is the all the things I put it here, the educational all the things, marital status, occupations, relationship, race, sex, all the things I put it there, all the data you can see the first 5 lines. Okay, then suppose I want to find any is null, any data is missing. So I find now here df.is null from this dot sum. So it is telling no, there is for that all data are there. Okay, df.shape you are finding it is 32,560 number of rows is there, and 15 number of columns are there. So df.columns, so all these 15 columns we can see, age is there, work class is there, final weight is there, education numbers, all the things are there. Okay, so then df.columns also you find it there, that no problem, what I told you same thing you get it there. Then df.income unique, so we divide into some categories, like less than equal to 50,000 and greater than 50,000, like that we put it there. So df.income, if value is greater than, so I am taking all the things. So these are all the people who are getting more than that amount of 50,000. Okay, so this is also then we tell the last also we take it that you see the Yeah, you can check it there also. Yeah, it's fine. Okay, tell means last 5. Then the var class, now we df dot var class dot unique. You see there are things like state government, there is a self-employed, then private or federal government, all the things are there. Okay, this is the actual American database we have taken. That's why federal we don't have any things like that. So if you go for the df var class, which is equal to np dot where df dot var class, so all the things you have given when it is np dot none df var. So if, okay, then you find the var class, there are 1836 values are there, right? So now df dot because where the data is not available, we drop it, and df dot na, then label also we put it there, then var class dot label, now it is what is state government, self, all the things. So where this type of things are there, no data is not there. So that because there are certain group of people who maybe they are not fitting to this type of classes, then you drop that one, right? So dot var class, then this is the var class, it is there, and df dot education unique. So we find bachelor's, higher secondary grade, 11th, all the things are there. So then education level also we have taken it here. So we put it, map it to bachelor is equal to 0, higher secondary grade is equal to 1, so 11th it is 2, master's it is 3, like that you put it there, because our job is to change the categorical into numerical values, that we do it dependent education. So all the things have done it here. Okay, now if you go for plotting income, here the income and versus the count, you find how many males having what is the income group. You can see it here, male is represented as the blue and the orange is represented the female. So you can see the count is, number of count it is here 14,000 are there, here some around 8,000 is there, all things you can check it here, fine. So this is the income, okay, and this is the count, right? So anyway, we have taken more than 50,000 rupees, there is nothing to worry, because the data I already refined. Now the native country, that is the native country value dot counts it. Somebody has taken. So now the native country, it is there, anyway it is showing some error. Then we have done all the things, then anyway all the things we can do, doing all the things, then occupation and unique everything, and something we drop, something we map it, then all the things we have successfully done it here, right? So the different race and everything, that also, and finally we find the df dot head. So you see everything, all these values are converted to categorical values, sorry, numerical values. So then while we go for the heat map, then plt dot figure 15 by 15, and you go for the heat map, we find all the things is the heat map for that one, right? Then what you do, df dot head, the first 5 rows we find the data here, and for feature is all the things. Then if you go for the box plot, you find the box plot here also. Now df dot describe, so we describe the what is the number of count is this one, mean is this one, standard deviation, minimum, maximum, all the things it is there, you got it done. Then trend test, we divide all the things there. So from escalon, pre-processing, import standard color, so we will divide into 70/30 or something like that, we divided, that is not an issue. So x is equal to x dot value, y is equal to y dot values, right? So sc with the standard color, and sc feed dot transform. So everything we have done it here, the output you can see it here, and x train, x test, y train, y test, here we divided into, that means test is 30% and training is 70%, that also you have done, everything fine. Then while you go for this precision, recall, f1 score and support, all the things we find it here. Then trees database, then while you go for this tree, the tree structure you can clearly see it here, and you can see the entire thing here also in the decision tree, how it looks, everything is successfully done. Now with open decision tree dot log, w as f out, and all things we have done it here. Figure also we field is equal to true. So with this thing, df dot feature dot names. Now if I go for the x train, so these are the training of the data is there. So now we using that one we go for this random forest classifier, because we have to build the model. RFC is equal to random forest classifier and estimate what we have already given, and then RFC prediction, everything we got it there, and also classification report. So from this we find the precision, the recall, F1 score, and support. So everything we got it here like this, right? Now then up to this we have successfully able to classify the entire thing and got the result using this random forest classifier. So thank you for watching this video. If you like this video, please do share with friends, and also if you want also the coding and everything I can share with you, plus just write a comment or do send a mail to me or SMS to me, so that I will be able to attach all this coding for you, and the data also data set also you can get it there. And here, as I told you that the data set what you are using, you can get it from Kaggle, so there is no issue on that one. And your data set you are using income underscore evaluation.csv. Okay, once again thank you for watching this video and have a good day. Thank you.